Hello, and welcome back to Algebra 1 Honors, Lesson 8-7, Functions Defined by Equations. Okay, what we're going to do today is we're going to look at equations in terms of functions. Okay, let me get rid of this real quick. Okay, so for example, let's just say that we, as a school, Sacred Heart School, are holding a big event, and it costs $5 to go to this event. Say it's a concert, okay? Who knows? Maybe some big groups come. And we have figured out that we're going to sell our tickets. We're going to sell our tickets for $5. Okay? But to set everything up and to decorate the gym and everything, it's going to cost us $500. So what we want to know is we want to know how many tickets do we have to sell to make a profit. Okay? So a profit we're going to call P. So the class profit, that means we're going to get some money back. Profit will be P. Okay, now if we sell one ticket, we get $5. We sell two tickets, we get $10. So the ticket price times the number of tickets is going to be how much money we take in. Okay, so our equation for this problem, our equation is going to look like this. Okay, well, if each ticket costs $5 and we're going to have N amount of tickets we sell, that's going to be how much money we make. But we also have to subtract the $500 that we spent to set up our party. So to get a profit, we're going to have to sell some tickets, and we're going to have to subtract $500 from that. Okay, the number of tickets sold minus the cost, our cost is going to be our profit. This is a function whose domain is the set of tickets that could be sold. Okay, the domain is usually what we call our x value, but in this case we're going to assign the domain to the tickets that we sell. Okay, that's our n number. So our domain is going to equal the number of tickets that we sell. We could sell no tickets. We could sell one ticket, two tickets, and on and on and on. As many tickets as we sell. The more tickets we sell, okay, the less it's going to cost us, and then there's going to come a time when we're going to make a profit. Okay, now, that's my domain in this problem, the number of tickets. Now my range in this problem, that's usually your y value, my range, okay, is the set of possible profits. And our range, okay, if we sell no tickets, if we sell no tickets at all, our profit is going to be negative 500. Oh, we're going to lose money here. And we keep selling tickets, okay, and it keeps going up and up by $5 increments until hopefully we've sold enough tickets that we're going to make a profit. Nobody wants to go into business and lose money. So, okay, this is an example of how you convert an equation into a function. Now, there's two types of ways to write a function. Okay, and we're going to use this to write our function, this equation. Okay, so I'm going to come over here and say my profit P equals 5n minus 500. Okay. Now the very first way that we can write this in functional notation is called the arrow notation. Okay, arrow notation. And it has an arrow in it. And it looks like this. An arrow notation will look like this. Okay, we're looking at profits, and then we have an N, an arrow, there's our arrow, and then we have 5N minus 500. Now we read this in a certain way. Okay, we read it, the function of P, or our profit, the function of P that is the function of P that assigns N to 5N minus 500. Okay, or we could say the function of P that assigns 5N minus 500 to N. Okay, that's called the arrow notation. And this is the notation I like to use. It's called functional notation. Okay, functional notation. And this functional notation is written like this. These are both written as functions. Okay, in this case, this says that P of N equals 5N minus 500. Or the value of P at N is 5N minus 500. Okay? Now, this is how we convert an equation into functions and to show that they're functions. But let's see, what does this have to do in real life in working out problems? Let's look at example 1. Okay, example 1. Example 1 says, list the range. Okay, first we have to remember what range is. List the range list the range of this function. Okay? If the domain is -1, 0, 1, and 2. Okay, here's the function. It's written in arrow notation. X is assigned to 4 plus 3x minus x squared. Okay, now it's going to give us the domain. And it says if the domain equals, and here's our numbers in the domain. Our domain is -1, 0, 1, and 2. Okay? Now what we have to do to find the range, okay, what we're actually looking for is we're looking for, when we plug in these numbers here, what will we get? Okay, so my range is going to be the solution of plugging in these x values. So domain is usually your x values. All right, so let's plug in values. All right, the first one is -1. So we're going to have, here's the first scenario. We're going to have 4 plus -1 times 3 is -3 minus -1 times -1 is 1. Okay, so we get 4 minus 4. So our very first one will be 0. Let's look at the second one. We'll plug the second number in. That's a 0. So 4 plus 0 minus 0 equals 4. Okay. Let's look at the third scenario. We're going to plug in 1. 4 plus 3 minus 1 equals, it's going to be a 6. And our last scenario is going to be 2, 4 plus 2 times 3 is 6 minus 2 times 2 is 4. So we're going to end up with 6. Now, as you can see, in our range, we have a 0, 4, a 6, and a 6. When you write them down, if you have two numbers that are the same, you don't have to write another 6. Because if you write 1, 6, everybody knows that 6 is in your range. So when I go over to solve this problem, I write my range is 0, 4, and 6. Okay? And that's the answer to that. All right? We took this function and we plugged in the domain and we got the range. Usually the range is called your y value. But in this case, it's the value that you get when you plug in your x's. All right, let's look at another example. Okay, let's look at this one. It says, if we have the same example here, and they're going to give us a functional notation here. Okay, we're going to look for our values. Okay. Yeah, I kind of like these. It says if you had this equation, and they write this, what is g of 2? I know this looks strange. What is g of 2? Well, what this means is that everywhere you have an x, you plug in 2 and you solve the equation, and the answer is going to be what g of 2 equals. What do I mean by that? Watch. G of 2 is going to be 4 plus 3 times 2 minus 2 squared. So g of 2 is going to equal 4 plus 6 minus 4. So the answer here is g of 2 will equal 6. Okay? Now, let's look up over here. You see they give you two functions. They give you a function that said let f of x equal x squared. G of x equals 2x. All right, let's just see what we did over here and see if we can redo it. What if I said, what is f of 5? Okay, well, what I do to solve f of 5, I look up here, and I have f of x equals x2, so f of 5 will equal x2, but I'm going to take my 5 now, and I'm going to substitute it where I had my x, and f of 5 actually turns out to be 25. Okay? Now let's look at g. Let's say we had g of negative 2. What is g of negative 2? Well, we take our equation and we stick in negative 2. 2 times negative 2. So g of negative 2 would equal negative 4. Okay? Now let's do another one that's just a little more difficult. Okay? It's going to combine two things together. It's still not going to be hard. It's going to be different, but not hard. Okay? All right, let's look at this one. Let's come over here and leave these guys up here. And let's do a problem from the book. Okay? All right, let's see. Let's do this one. Fg of negative 2. Okay? We're going to look at this. We're going to come over here. Okay, F, and then we're going to have in here g of negative 2. Okay? Fg of negative 2. Okay? Okay. Now, to solve this problem, we have to use two steps. Okay, first we have to find out what g of negative 2 is. And because it's g here, we're going to use this one. We're going to use this. G of x equals 2x. Now, g of negative 2 is going to equal 2, and I'm going to substitute negative 2 here. So g of negative 2, the new name, is going to be negative 4. So I can come up here and rewrite this one, okay, as this. Now I'm looking for f of negative 4. Okay, it's a two-step process. So now I see, oh, well, the f function says f of x equals x squared. So f of negative 4 is going to equal negative 4 squared. So f of negative 4 will equal 16. Okay? And that's just about all there is to this lesson on functions.